Hello viewers, welcome back to my channel where we simplify clinical data standards for everyone. In today's video, we will break down the essential rules for creating rows and columns in ADaM datasets based on the ADaM Implementation Guide version 1.3. Before we see the first rule of creating the rows and columns in ADaM datasets, let's understand how that rule can be seen in implementation at the analysis level. So right now I have shown you a mock shell where you can see that for the set test we are having the information as observed or the change from baseline for both of the arms created here. In baseline we are giving the statistic data, and after the baseline visit we have the next visits, which is the week 4 and so on. So this is a mock shell, so for your study it can differ, but the main point to note here is that along with the baseline visits, we are displaying the post baseline visits also, and we have a information which we want to display, that is the change from baseline for the post baseline visits. So now the question arises is that how and from where this change from baseline is being derived or populated here. As you know that the observed values are the values which are being collected at the investigator site and are also present in SDTM, and then from SDTM it comes from to the ADaM level. So those are the collected or the observed observations in the ADaM dataset. But to have the change from baseline, you will see that this change from baseline information, we want to have it for each post baseline record. So in this case, what is the thing which we have to see is that we have to derive the change from baseline for each post baseline records irrespective of the param series we are talking about here. As you can see here in this mock shell, we have it is nowhere mentioned that this mock shell is specific for any particular param CDs here, although the title might say diastolic blood pressure, but the same can be achieved for all of the param CDs in your ADVS, ADLB, ADEG, any BDS datasets here. So to derive the information for change from baseline, what we need is we need the information of the result in your A-val for the post baseline records, and then we will have to compare the post baseline A-val value with the baseline value to get the change. The change is derived as the A-val minus the base value, so that is achieved on each record level irrespective of the param series. So from this you can understand what is the rule 1. The rule 1 says is a parameter invariant function of A-val and base on the same row that does not involve a transformation of base should be added as a new column. So here we can see then when we are deriving the change from baseline information, that is independent from the parameter. That means that even if the parameter changes, the formula to calculate the change from baseline will be the same, and it will depend. Another point to note here is it will depend on the A-val and base values on the same rows, and it does not involve the change in the base values of the record. So in this way, you can correlate with the example and understand what the rule 1 says, that whenever we want to create a parameter invariant function of A-val as well as base or for the same row or record where it does not involve any change in base value, then that information should be captured as a new column as per the rule 1. Now let's go through another form here. So right now I'm giving you a CRF form where you are capturing the vital signs information, and in this form you can notice that the VS test is being captured, and we have the position, result and unit information as well along with the date. In this example, the height is a pre-populated form value in the CRF form, so we from this form we know that this CRF form will have the VS test equals to height. And depending upon what the unit we are populating or we are capturing at the site level, it might impact our population of the height in centimeters in this listing output. So here, if for an example, at the investigator site, the unit in which the height is captured is not centimeter, say it is in some other units, then we will have to change the unit of height to centimeter. So for that, at the ADaM level, what we have to do is we have to create a new parameter with the information of unit mentioned along with its param value in your param value. So in this case, although the captured unit, the param CDs will be height within the respective captured units, but you have to create another param CD or the param values where the height and units will be in centimeters. So in this example, the same can be applied for weight also, where the weight which might be captured at the site level in your pounds value, but we for this listing as shown and as an example, you want to display the weight in kilograms. So to achieve that, you will create another param CD for weight as well with the param value of weight in kgs, and this will be created as a new record here. So based on this understanding, the rule 2 says a transformation of a val that does not meet the condition of rule 1 should be added as a new parameter, and a val should contain the transformed value. So here please note that the rule 1 state that the base value should not be transformed, but when you will change the units from one to another unit, you will have to change the base value as well. And it will also involve the transformation of a val which was captured at the site level. So because of that, we have a new rule created that a transformation of a val which does not meet the condition of rule 1 should be added as a new parameter, and a val should contain the transformed value. So in this example, we will be creating the weight in kgs and height in centimeters if the value which is captured at the site levels are not as per the in the required units which we need for analysis purposes. In this example which I'm showing you, we can see that for the systolic blood pressure for this said subject, we did not had the visit 8 information being captured at the site level. So to avoid any missing data for analysis purposes, what we have done is we have created two more records where the D type is letting us know that what these two records tell us. So from the D type value for the record number 7, we know that this record for week 8 is the last observation carry forward record. And for the record number 8, the D type is WOCF, which is the worst observation carry forward from the visits prior to week 8. And you can see for this records, the worst observation was for week 4.1. Hence, all the values, which is VS sequence, eval, base, change, and remaining all variables are populated from the visit 4.1 for WOCF, and same is the case for LOCF also. So what we have done here is that when you are deriving the LOCF or WOCF, what we have done is we have taken into account the previously or the available visits for us for the same parameter and created a new record for the D type variable. So if we see from rule 3, what we have done here is that we have taken a function of one or more rows within the same parameter for the purpose of creating an analysis time point, and we have created a new row for the same parameters. So this is in sync with the rule 3, and we can say that the rule 3 is a function of one or more rows within the same parameter for the purpose of creating an analysis time point should be added as a new row for the same parameter. Points to note here is that we are considering the same parameters rows and we are creating a new record for the same parameter in rule 3. Rule 4 is a special case of rule 2. The function covered by this rule violates the second condition of rule 1, that is, they are not same row functions of eval, and may also violate the first and third condition. So right now in this table, which I'm using as an example of a clinical trial for HIV vaccine, you can see that blood samples were drawn at each visit and CD4 cell count is being measured. To assess efficacy, it is important to look at the cumulative effect over the time of CD4 cells count during follow-up after administration. So what we have to do is we have to create a new parameter which is the param CDU4 AUC as well as the CDU4 AUC MB, and these two parameters are a function of the A-val based on its time and the visit day Y. So since the records which are created for these new parameters, that is CD4 AUC and CD4 AUC MB, are dependent on multiple records of your collected param CDU4 and is dependent upon the visits and visit dy, that is, it is dependent upon the time these observations were captured. These param CDs needs to be created as a new record. So as per rule 4, a function of multiple rows within a parameter should be added as a new parameter. This example might seem little complicated as this is an param CD which is not commonly being seen in the clinical data sets. I'm giving an example of area under the curve which is used for the peak analysis as another example for rule 4. Now again, I am showing you an example of the PK datasets where you can see that for a particular subject we have data for visit day 1 and we have the plasma concentration captured for the drug A in this example. The next thing which I am showing you right now is the plasma concentration being plotted based on the time. So as you can see that for when your subject is injected with your drug A, the concentration of that drug will increase, and the same is being shown in your diagram here, that as the time progresses and for each time point when a new dose is being injected in this subject, the dose concentration is increasing, and after that a threshold value is achieved, after which, since there was no additional dose intake, the dose concentration is now getting reduced or getting washed out from the system, and hence there is a decline in the plasma concentration, and with time you can see a plot curve is being created based on the plasma concentration. So now when we talk about the PK dataset, the PK dataset is only capturing the plasma concentration based on the uh, time points or the visit. But when you want to do any analysis, what you will need is you will need the area under the curve, the Cmax, Tmax, see-through parameters for this plasma concentration. So normally what we see is that these parameters which we need for our to create the summary analysis, these parameters are provided by the vendors here, and we can say that analysis which is being done are done by the PK scientist, and they derive these parameters, that is the AUC, Cmax, Tmax, see through all these parameters and provide a PP dataset. But these informations are being derived from the dataset, which from the information which is captured in your PC domain, that is your plasma concentration. So these informations are derived, and what we have done is that we have created a new parameter for analysis. Ideally, normally, these two informations are being captured in your PC and PP datasets and is provided by the vendors as a part of your SGTM datasets. However, there can be scenarios where the PP dataset information is not provided by the vendors but is being derived at your ADaM level. So if that is the case, these information which is being provided in your PP dataset, when you create in your ADaM datasets, you create these as a new parameter for analysis. So what we have done is that in this case, we have used the existing parameter, that is the plasma concentration, and we have used the multiple rows within a parameter here, and we have derived a new parameter for our analysis. Talking about, for example, the area under the curve. So area under the curve, which is your AUC, what we have done is from time point 0 to till time point t, we have seen the concentration and we have derived the AUC, that is the area under the curve, by its respective formula and created a param in your ADaM level, that is the AUC parameter. The same can be seen that we have, based on the data which is captured over time for the plasma concentration, we have captured the Cmax, Tmax, and C through also. So if we see the rule number 4, rule number 4 says that a function of multiple rows within a parameter should be added as a new parameter. So now the point to note here is that what we have done is we have considered the multiple rows for the parameter which was the plasma concentration captured in your PK dataset, and using those multiple rows you have created a new parameter, and as per rule 4 this parameter should be created as a new record. Some might argue that the PCP and PP datasets are a part of SDTM transfer, and those are the collected informations and not the derived parameters in your ADaM datasets. But the key point to note here is that these records are being provided by the vendors, where the vendor PK scientists do derive these values in your ADaM in your SDTM PP datasets. But another point here is that even though PP is SGTM ready datasets derived value, in ADaM you do not just copy them blindly. You represent them as a new parameter in the analysis ready structure, keeping traceability back to PC or the PP, which is the derived datasets. Now let's understand this demographics and baseline characteristics mock shell. Here in this mock shell, you can see that we have a BMI param CD information being displayed along with the height and weight. Height and weight are the two param CDs or the test which are captured as a part of the vital signs in the clinical studies at the clinical site level. However, BMI is the param CD which is being derived at the programming level from weight and height. So if you want to display the BMI category in your demographic baseline characteristics table, we will need to create this BMI param CD in your ADaM dataset, which can be your ADSL dataset here. So as per the rule 5, what we can see, taking into in consideration the example of BMI, which is being created from two parameters, Rule 5 states that a function of more than one parameter should be added as a new parameter. So because of this rule, you can see that BMI being created from two parameters is added as a new parameter in your ADaM level. So any param series which is a function of more than one parameter should be added as a new parameter in your ADaM level. Now, before we see the rule number 6, let's see what this mock shell table is showing. Please note that for data confidentiality, I have masked the treatment arms for this mock shell. This mock shell is capturing the change from baseline scores by time points for the EQ5D5L questionnaire form. Please note that the time points which we have to display are the baseline and all the respective time points, say time point 1, time point 2. And based on your study, the time point 1 and time point 2 values can be 1 hour, 2 hour, 6 hour, and so on. Another point to note here is that in this table, for statistics value, we are not only populating the base value, but we are populating the change as well. So as we all know that change is change from baseline, and in simple or a regular data set, the change from baseline can be derived by applying the formula of aval minus base, and the base is the value which is taken from the record identified as the baseline record. We identify the baseline records by creating a variable which is ABLFL, and when this variable is populated as Y, that record is considered as the baseline record for the data, that param series. Now, since we have to populate the change for time point 1, time point 2 here, what we have to do is we want to know what was the base value for that time point. We cannot take the baseline value in this example as your base for time point 1 and time point 2, but we have to identify the base value for each time point respectively. So to achieve that, what we have to do is we have to create another column, which is the column base type, and we will have to identify the base values for each time point similar to the way where we identify the baseline records for the said param CD. Once that is identified, what we will have in your data set is that for each time point, there will be an identified record for which the ABLFL will be marked as Y, indicating that this record for which the ABLFL is populated as Y is the baseline record for this time point. And to provide this description, we have the base type variable where we can mention that this is the baseline for time point 1. And similarly, when we derive the baseline record for time point 2 with ABLFL as Y, you will have the base type value populated as baseline for time point 2 and so on. So in this way, what is happening is that you have different definitions being populated for base type. That is, for baseline record, you will have as baseline, but for the time point 1 and time point 2, you will have the base type populated as baseline for time point 1 and time point 2, respectively. So what is happening here is that in this table, what we have done is we have created more than one baseline definition, and we have created new set of rows for those time points. When this is the case, the roll number 6 gets into its impact. The rule number 6 says when there is more than one definition of baseline, each additional definition of baseline requires the creation of its own set of rows. So as we have discussed in this example, when you will derive the baseline records for time point 1 and time point 2, you will need to create a new set of rows for these time points to identify the baseline records for these time points and hence populate the base type variable. That's all for today. Thanks for watching. Let me know in comments if you want me to cover any specific topic.